all the platforms. I also want to figure out how to fix YouTube so it's not subscriber only on the chat. I don't know why it does that. Confused. All right, let's see. There we go. Activate. And then let me fix this maybe. It should go live. Don't steal my stream key, please. There we go. So now we're live. And then I think I want to... What's up, Crazy Run? There you go. I want to see if there's a way for it to not be subscriber only. It shouldn't be set here. Stream settings. What is it under? Ugh. Google's the absolute worst with hiding their settings. I think it's here, actually. Here we go. Here's what I have to do. Customization. Participation. Who can send messages? Anybody. Set it to anybody. There we go. Okay, so anybody should be able to send a message now. I think it's fixed. All right. First question of the day. Let's see. We got Steph, Gladiator, and Breasticles in the queue. Let's go pick a winner. Ooh, looks like it's gonna go to Gladiator.
That's dope.
All right, Gladiator, you're first, dude. Gladiator's asking the OChem questions, which I actually don't know how to do. Where's JC? Where's my CEO of chemistry, dude? Oh man. Show that the polymerization of 4 units of the following monomers and state the type of polymerization reaction. So I'm just gonna kind of like try to figure this out myself. Poly usually means many, right? And so polymerization, I think, means taking many of these to form what's called a polymer. And a polymer is something that just has a bunch of different molecules together. Huko, isn't that a famous YouTube girl?
Huh?
I don't know. Who's Huko? Huko. Man. All right, let's go learn with AI, because I don't know what this is. It's all good. Oh, Hawktua. Oh. Didn't that girl go on, she's given in, hasn't she, right? Her fame isn't working anymore. She's going to OF. That's what I saw. I'm like, oh no. The inevitable progression. Okay, here we go. The monomer is known as styrene. Oh, okay, so this is cool. You guys, so if this is styrene, right? Then the polymer form of it is polystyrene. Do you guys know what polystyrene is? You may have seen it before in like plastic cups and stuff. This is polystyrene. You guys ever see, this stuff is terrible for the environment, by the way.
Disqualified.
We've kind of like started to ban it. Like you're not allowed to like do polystyrene stuff anymore. But yeah, there you go. Yeah. You guys ever seen like little like packing cubes? It's like is it like styrofoam? It is styrofoam. Yeah. Okay. You're right. Yeah, polystyrene is styrofoam, I guess. Yeah, I think most people call it styrofoam. I agree with that. Yeah. Okay, cool. So yeah, this stuff. This is polystyrene. Okay. So the polymerization of 4 units. And so, yeah, whenever things polymerize, it means there's multiples of it. There has to be, I think, what's called like a repeating unit. So you need something that repeats. And so in this case, they say that this part, the CH2CHPH part, is the... All right, so let me pull this back, yeah. CH2, what did they say? pH? Or what's the P? Oh, the pH is the phenyl ring. Oh, okay. Uh-huh. So, okay. CH2CPH. So it says the CC double bond opens. Okay, so this thing opens. Drew Taylor? No. Well, Drew, you submitted your question at like 6 a.m. Can you resubmit it? Like we clear the queue once the stream starts every time. Just to so otherwise anything that's submitted before the stream starts like accumulates like way too many votes once the stream. Yeah, you got it. Okay. I could go through an A-level further math. Yeah, if you want to send me a screenshot, I won't do the whole thing, but if you send like one of the questions you want me to go through, I'll go through it for sure. Should I put my... I don't care. Whichever one you want. I mean, you can put Drew Taylor. I know who Drew Taylor is. Okay. No small molecules eliminated. It forms a carbon-carbon backbone. Initiation includes radical initiator. Wow. Okay. This is where I think we can just kind of Google this, right? Styrene polymerization. Bingo. Cool. Uh-huh. Okay, I think I see what happens. What's up, user? The website is called Physics and Math Tutor. So if you just take a screenshot, send it to that website, actualofficehours.com, it'll get put in the queue, and then we'll go do it. So here, I'll just do this first one for you, and then I'll tag JC to maybe take a look at it. But I think what happens here is that this carbon-carbon double bond opens up, and that then enables another styrene thing to bond to this one, right? And then this one bonds to this one, and then this one bonds to this one, and so forth and so forth. So this would be here. This is your 4 units. This is 4 units of polystyrene. And what else are we asking for? The type of polymerization reaction. Good question. Okay, what type is that? And it's called addition. Free radical chain growth polymerization. This is OChem. Someone asked an OChem question, user, so we're just doing a little OChem question. So there you go. So that's the polymerization. I think it's because this must bond out and then the electron must go somewhere else. I'm trying to think how this works. Yeah. Actually, I think the electron goes here, because then once you have an extra electron here, that then enables another thing of polystyrene to bond on this side to it. I think that's how that works. Addition, because you're breaking the double bond. Right, okay, cool, yeah. You break the double bond. I think you break the double bond on each one, right? Everything of styrene here breaks the double bond, which then allows it to bond with the other one. That's cool. Okay. Yes, we do get tons of viewers, so now we have to draw them randomly. Although, okay, cool. I'm going to say I did this one, but then I'll tag JC to see if JC wants to do the rest of it. But hope that helps so far. Okay. Dun, dun. All right, we're going to download that screenshot, put it in. This was Gladiator. Dun, 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 dun. Oh, dude, where is... I cannot drag this. Drag. There we go. Okay. And then I'll tag JC in it. To do the first one. Maybe if you have time, you can help with the others. Okay, cool. All right, let's go see what the next question will be. Steph's got the most amount of votes so far because they were submitted the furthest back. I love how... Do you see how we have independent timers on things? Oh, Ramton, what's up, dude? Sorry, I didn't see you.
Hey, how's it going?
Good, good, good. We have a new... You're good, you're good. We have a new, like, random question selector thing that we created.
Oh, it's an interesting one.
Yeah.
How does it work?
So when people submit a question to the queue, it starts accumulating votes. So here's like how many minutes ago everyone's question was submitted. And then every 3 minutes, people can upvote the questions. So it's kind of like if you stick around and you like keep hitting upvote every 3 minutes, then you boost the chance of your question getting selected. And then this is random.
I like that. I like that.
So here, we're going to do a little spin. We're going to spin, see who's going to win.
Oh, wait. Okay, this is actually...
I vibe coded this in like an afternoon.
That's a good idea. I mean, you use AI to do that?
Yeah, this is all done with AI.
Yeah. What do you use for the animations? I wanted to see.
That's all coded with AI, and I think it's literally just like a PHP thing, or it's like maybe it's JavaScript.
No, I mean, like, which AI did you use?
Oh, I used a combination of Claude and Codex.
Okay. I haven't used Codex, but yeah, Claude is definitely the...
Super powerful, yeah. Gladiator's asking, why is the upvote cooldown different for each one? Okay, so here's the thing. I used to have it that it was per IP that you could vote on certain questions and there was a cooldown, but then people found ways to circumvent that by just like opening multiple browsers, which apparently opened up multiple IP addresses. I didn't know it does that. I thought IP addresses were like location specific. Like if your access point is this, doesn't matter how many tabs you have open or how many browsers, it should be the same IP. Yes, Breasticles found a way to break it. So I had to change that to now it's a global cooldown on all the questions. So each question has its own cooldown timer regardless. Originally I wanted like if multiple people liked a question, multiple people could boost it more, but then it was shown that it's pretty easy to just like fake being multiple people. So now we have it so it's strictly one upvote every 3 minutes per question. Yeah. The issue with the question, I don't think is defined. Could you make it so the spinning wheel isn't global? What do you mean global? I mean the spinning wheel is based on all the votes. Whose question? Sorry, who's we doing so far? Sorry. This is Haunted's. Okay, Haunted. Here we go. Define the operation heart on Q by AB heart XY gives you A to the Y, B to the X. Show that heart is not well defined with respect to tilde. What does this mean? What is tilde? Here, Rascals, wait, you want to come up?
The tilde is the equivalence relationship on Q. So it basically says that if you take two pairs, because we define a rational number as an integer over another integer. If you take two pairs of integers, the the rational number that you get from those pairs, they should be equivalent no matter what you choose.
Okay. Yeah, it is math jargon for sure. Okay, let me think. So equivalence relationship is the tilde.
Like something like 1/3 is equivalent to 2/6.
Oh, okay. Like that.
Yeah, pretty much.
Yeah, so these are considered equivalent ones, but so like sometimes it's like they're different numbers, but they're equivalent.
Got you. Okay, but the ratio of them is okay.
So I think what it's asking is well, if it's not well defined with respect to that, you would basically have to prove that under that operation, it doesn't obey that equivalence relation using those pairs. if I'm not incorrect.
No, you sound more correct than I do. I'm totally fucking lost.
I'm slightly lost too. I avoid
That's-
proofs
that-
in my math.
I
avoid the
know. I
rigorous
usually
stuff.
I usually hate proofs as well. But
I think
Rampton.
from what I understand, hope you don't mind I'm jumping in.
No, please take over. What's up? How do we do this?
But I think what it means that the only way to get an operation between two pairs of points to be equal to each other is that those pairs of points all need to be unique. So if like I choose A, B, and X, Y as like different values, I can't get the same exact thing A, Y equal and B, X. So for example, like 2 to the power 4.
Yeah.
So if I choose like
A equals 2,
to the
Y equals 4.
equals 2, Y equals 4, right?
Uh-huh.
So that would be equivalent to if A was 2 and Y was, or say A was 4 and Y was 2.
And Y was
Right.
Y is 1
to
though.
the-
No?
Because
Oh no. I see what you're saying. Sorry, my bad. Yeah.
Yeah. So something like this would
Yeah,
create
2 to the 4th is
equivalence
equal to 4 to the 2nd. Uh-huh.
Second. Yeah. And
Got
then-
you.
Yeah, so this would be an equivalence one to show that thing is not well defined. I'm trying to understand what it means, but show that heart is not well defined with respect to.
So I put it in the GPT because that's usually how I start on proofs, just to get the start going.
How does chat
Basically,
do it?
what it says that because exponentiation depends on the actual integers chosen in the representative, and equivalent pairs can produce non-equivalent results under heart, then the operation is not well defined. So it's basically saying that because it depends on what you choose for y and x, and 2 equivalent pairs of integers can create different results, and it's not defined, I think.
Okay. So for instance, I mean, if A equals 1 and B equals 2, but X equals 1 and Y equals 1, that would produce 1 to the
Anand
first.
sent the definition of the. We say that an operation is well defined with respect to the equivalence relationship if given the set AB and CD.
Mm-hmm.
Then for any set XY or any pair XY contained in the set, pair AB and WZ contained in CD, we have XY times WZ is an element of AB times CD.
I'm trying to follow all the letters. Too many fucking letters in this thing. Okay, but yeah, all right. This is what Haunted said. Haunted. This is the hint you were talking about, right? Breasticles, yeah. Don't you just have to find a number it doesn't work for to show that it's not equivalent? Sure. Okay. We say that it is well defined with respect to equivalence if given, okay, two points for any XY is in AB and every WZ is in CD, then, oh, okay. Doing this is also contained, X, Y, and WZ is also equal to A, B, and C, D.
But I'm a little confused as to what does the bracket do? Why is there a double bracket with AB?
Yeah, why is there like a parentheses
Yeah.
and then a bracket?
Yeah, is that supposed to be? Because what I thought it means is that if you pick a pair of points within a certain interval, and then another pair of points within another set of interval, then the operation between those 2 points has to produce another pair of points, which is an element of the same operation within the 2 intervals.
Okay.
So I think I don't think intervals are involved. Yeah, he says I don't think
The
intervals.
the bracket would be either a class or a set usually.
Yeah, someone says this is
the equivalent classes. Okay.
equivalent class. What math is this, by the way? Is this discrete?
This is probably either a foundations or analysis class, I think.
Damn, yeah, I never took analysis. Zach, where are you, dude?
Intro to proofs. Yeah, that checks out.
Intro to proofs. This is crazy. 1, 2 equals 2, 4 equals 3, 6 for rational numbers. Okay, well, I get that, right? Because 1/2 is the same as 2/4 equals to 3, 6. And then, sorry, is the operation division? Is that what we're showing? For that one, Jeff, that example? Abstract maths. Y'all blowing my mind today. Okay, so, but this operation... Oh, I see. Okay. I think that's how pairs are defined in Q. AB means A over... Oh,
okay.
You're saying that A comma B is the same thing as A divided by B? And that here that like... Oh, thank you, Joseph, by the way. Gladiator, Joseph went through and solved your OChem question. W, Joseph. I love you.
Okay. Now I get the question.
You get it?
Now I
Okay.
get the question. At least I understand what it's asking. Okay.
Okay, good. We're making progress.
Yeah. So
Okay.
I think what it's saying is that if you take a pair of points AB and XY,
Uh-huh.
and again, AB is defined as A over B, and then
Okay.
XY is like X over Y.
XY is divided
If
by...
we take another equivalent point to AB,
Okay.
let's say CD is equivalent to...
Okay, let's say like AB is equivalent to CD, which an example for this, right, could be 1/2 and 3/6, right?
Yeah.
Okay.
So, and then XY, again, another pair of points we would have.
Okay, so let's say XY is equivalent to, what are they saying, WZ? Yeah, WZ.
I think we need to use it for this one. I think we'll just do XY, let's say
Or we're just going to give what
1/2.
XY is?
Yeah, just another like random.
But
pair of
does
points.
XY need to be equivalent to AB and CD, or no? It can just be whatever.
No, I think XY.
Anand said the equivalence class of AB is defined as XY is an element of Q where AB is equivalent to XY.
Okay. So what could XY be equal to? Just whatever. This is where I'm curious. I'm like, wait, but what is XY then? Who was phone? Okay, someone said 3/4. I like 3/4. Okay. All right, let's just do it. Okay.
From what I understood, I think from what I understood is that if we take a equivalence, I think maybe breasticles. That's an interesting. Breasticle could correct me if I'm wrong. But if we take another pair of points which are equivalent to AB and another pair of points which are equivalent to XY, we cannot produce an equivalent class for AYBX.
A to the Y, BX. Okay, so A to the Y over B to the X. Okay, so what would that be equal to? Okay, so A to the Y, that would be 1 to the 4th over B, which would be 2 to the 3rd. Yeah? And I can't make something... Oh, okay. And you're saying that I can't make another thing that's equivalent? So if I were to do 3 to the something over 6 to the something, I can't also get 1/8 somehow?
I believe that's what it is asking. That's what I...
Good job.
Okay.
And like if you pick another pair of points which are equivalent to like 4/3.
Right. I need this thing,
so
right?
maybe,
Which is basically
like 8/6 or something.
Was it 8/3? Sorry. Because it was YX. Yes. Okay.
Yeah.
So like that 4/3 or 8/6. I can't also get something that's equivalent to 1/8.
To 1/8. Yeah. So I mean, this is like obvious for this one, but then the question is,
What is this
Can we
meme?
prove that for all fair points? Analysis, to be honest, is my weakest point. So it's.
Oh, I like that, Drew. I will add that. Yeah, that's a good one. Yeah, we have we have this Walter White.
Hey, come on, baby! Come on! Yes!
But yeah, okay. I need the wire. Dude, I think that's seriously where I'm at right now. I'm like, wire. Okay. So is this just an example that there's no way for me to get 3 to the 8, but this is like just something that's equivalent of 4/3 to get me to 1/8? That's so nuts. How do you prove that?
It would be, I believe you'd prove it through contradiction, because I want you to show that it's not well defined, so you just have to show an example. That
Oh, I
shows
just
that it's
did?
not well
Oh, I
defined.
just showed it. Oh, I just showed
like
it.
when chat did it, they just used different values for x and y. They used 4 and 2, and then
Okay.
they showed that it doesn't result in equivalent pairs.
Okay, so this is basically it. We did the proof. Yeah, because this doesn't equal this.
I feel like
What's an
I'm
operator
not-
where it is equivalent though? What would be a cool operator? Maybe like A times Y, B times X,
yeah, I think that would make sense.
right?
On its head, I think the first step is finding the equivalence class for AB and XY. Yes, I believe so.
So let's say I came up with another like operator. I just want to show one that would maybe work. Okay, they have heart. What's the other thing? Okay, I'm gonna put like a star. Okay.
Yeah, I think Jeff mentioned one.
Yes, there we go. Okay, is equal to AY comma BX. Yeah, let's say this was the thing we wanted to prove that's equivalent. So yeah, 1/2 is equivalent to 3/6, and then 3/4 is equivalent to 6/8. So
You get
okay,
6 over 6 and 24 over 24.
right, because AY ooh man is 1 times 4, right? Is that right? A times, did I get that right?
1.
Because this is then AY over BX.
Yeah.
Yeah?
I think.
You gotta do that right.
Yeah, so I think your pairs of points, your AB is 1/2, 1, 2,
Mm-hmm.
and your XY would be 3, 4, right?
Yeah. So is 1/2
Oh,
3/4?
yeah, I can't do math, sorry.
No, 1/2 4/3.
That's-
Is 1/2 4/3 equal
Yeah.
to 3/6 8/6? Yeah. 4 over 6 equal to 24 over 36. It is. They're both 2/3. Oh fuck yeah, dude. There we go. Nice.
I think AXBY would also work, hopefully.
Okay.
Yeah.
Okay.
I feel like there's the other question that it had. If you wanted to do a direct proof, I feel like I'm not nearly cracked enough for this level of analysis, even though it's introductory. But I feel like if you were to define A, B, and X, Y in terms of their prime divisors, in terms of their prime factorization, then you could also show it that way.
Cool. Okay. I think I learned something from here. I'm gonna put this in the Discord. If you guys want to if someone wants to later come up with a cool explanation for it, I'll show you where it's gonna be. I like the proof by contradiction, and then also I feel better about myself because I think I understand what equivalence is from an operator that is well defined. So this was haunting me with with the real analysis today. Jesus, that was fun. But yeah, so here, this will be in our Discord. So if you go up here into homework help, I've got to refresh it sometimes. There we go. There's Haunted's question. Wait, did they change something on... Oh my god. They changed this on fucking Microsoft Edge. You can't drag things from the download folder anymore. God damn it.
Surprise, motherfucker.
Anyways, it's right here, Haunted. You get a point for that too as well. I appreciate the question. I appreciate Ramton and Breasticles for saving me, because I have no fucking clue how to do real analysis. But I'm learning slowly.
I'm just spitting ball.
I'm slowly learning too.
Dude, there you go. Yeah.
I've avoided so many proofs class.
You'll send your answer later. Awesome, Haunted. Yes, cool. It's right there, Haunted. If you want to like dump it in here, I would love to like go look at it later. Microsoft Edge is the #1 reason people use Chrome. I just don't want to use Chrome on this PC because it's tied to my Google account and like God knows what. And I want this isolated. I just don't want it.
You don't want the stream seeing your search history, is what you just said.
Surprise, motherfucker.
Yeah, I don't want them to see what my autocomplete is. So like I to just fix that, I put it on a whole other fucking browser. I'm just like, nope. This browser is only for education stream stuff, not, I don't know, like weird horse pictures or something. Yeah. You just needed a push. Okay, great, Haunted. I'm glad. All right, glad it made sense. Yeah, I could do profiles, but then they still have like fucking logins and shit. I don't want to deal with that. All right, let's go spin for another question. Let's see. Breasticles is currently on top. Breasticles, what do you bench, dude? You can't have the name Breasticles if you don't bench.
I honestly don't even remember what I used to bench. I don't bench anymore. I got in a car accident, so I have 2 herniated discs in my lower back. So
God damn it!
I can't really do anything.
Okay. Well, I apologize for that happening. That sucks.
Nah, you're good. It is what it is.
It's like, why are you a bitch? Why can't you like bench? And he's like, well, I got in a car accident and I lost like 2 herniated discs. Like,
I would, since everyone's listening, I would also like to give a piece of advice. Don't push your body, especially if you're too young, to like get up and weight really fast.
Yeah.
Because your muscles will recover, but your ligaments wouldn't. I ended up tearing my ligament because I was trying to push it 225. Like I was getting a lot of thing. When I started off, like I came off sitting on the couch for like 2.5 years.
Yeah, you used to be like a fat ass dude, but then like you got like really ripped and stuff because you started doing judo and stuff, right? I remember that. I remember that story.
Yeah.
Muay Thai, that was it.
And then, this happened to be like 8 months ago. I pretty much like started off with like 260.
Damn, big weight.
And then I was like going down in weight. I got to 200 and my bench was going up. And I was almost at 2 plates. It was like a plate and 35. And then one time I was like, oh, my left arm just completely gave out. And then turns out that I tore my tendon. Thankfully, it's a very light tear.
Okay.
But just say like tendons don't handle load.
They really don't.
Increase in load.
Yeah, or impact. I got
or fucking cars.
Tears in my knee. Yeah, I got a grade 2 partial in my ACL and my MCL.
Jesus.
That is.
And they didn't call me about it to tell me until like a couple months later. And so when I bought a new car because my truck got totaled, I was like, a manual would be fun to drive. And it's in my left knee, so.
Oh no, the clutch. The clutch.
Yeah.
Clutch life. I'm kind of going through a similar thing. I'm pretty sure I fucked up my rotator cuff like 2 months ago because I haven't done bench for like the last month. And in December I got up to 3 plates, Ramton. This was like the most I've ever done in my life. Yeah, I wanted to just hit this once, and I also like gained a ton of weight. I gained like 40 pounds in the course of like 4 months of just like eating like crazy. But I did this once, and I just wanted to do it once because now like
it's clean.
It was a clean one, right? Yeah, but I went to the gym today to start benching again after taking a whole month off because I'm pretty sure, I screwed something up. I can't do 2 plates.
Yeah, it's you like lose it quick. But here's the thing, though. I would say this, not to get off topic too much, but
it's okay.
When you build muscles, and when you like so-called later lose the muscles, you lose activity, but when you
Okay.
build the new muscle fibers, you never lose those. So that's
Oh,
why
so you don't lose the
regaining-
mass.
You don't lose. Well, kind of you do, because the muscle gets deflated. Like the cells get deflated.
Yeah.
So like on a scale, you've lost it, but you haven't lost the fibers. So if you start taking creatine and you go back to the gym, it takes you apparently a quarter of the time to go back to whatever you were
Oh, okay.
before when you got there.
That's
first.
dope.
Nice.
That's why
Quarter of
like
the time.
gaining weight and losing weight works really well, because you don't lose the muscle.
It just doesn't get as
And-
saturated with like
It does,
fluid and stuff.
exactly. So the next time when you're gaining weight, you're gaining your old muscles back
Mm-hmm.
and new muscle fibers. But here's also the thing: that also happens to your fat muscles. So whatever fat you gain, when you lose weight, you also just shrink them. So when you gain the weight again, you're also building new fat cells.
Damn it! I'm
So,
building new fat muscles.
You get more jacked and more fat. That's why dirty bulking is like tough.
Dirty
But if you do a clean bulk, like apparently if you wanted to like do a clean bulk, you're supposed to gain 2 to 3 pounds a month. So in a year,
Yeah.
you like have to gain like a maximum of like 20 pounds. Per
Yeah, I
year.
gained like 40 pounds in like 6 months. I just ate everything.
Yeah,
It was
that's-
terrible.
Just
I just wanted to
ice.
hit 315. I was fucking eating ice cream and pizza and everything. I was like, just
Honestly,
eat mass.
sometimes it's worth it. You hit the 350 now. you
I
have
did
to
it.
put
Yeah, I did it once. I can tell my grandkids or my whatever at some point.
I
Yeah.
just do it to enjoy life. I
Yeah,
spent the
dude.
entire summer. My diet was just steak and beer.
Hell
That's
yeah,
the life
dude.
I ever lived.
Good job.
Steak and beer. Yeah, that sounds dope. That's like, I think there's that one was that one like MMA fighter or something. He's in an interview and he says like, all these people are miserable, dude. I'd love just being fat and happy. He's like
Oh,
fuck.
Patty.
Patty, is that his name? Yeah,
Yeah, Patty Pimblett.
that's a great quote.
It's a Scouser. It's like from
Scouza. Haley says, which one do I submit? There's too many options. Oh, okay. Here. All right. Someone in TikTok doesn't know how to submit questions. It's okay. So here, where it says submit your question office hours, just put your username in here, drop a screenshot, and then you see this like this pulsing, glowing green button. I did that on purpose. That's the button you click to upload. And then once you upload, it gets put into the queue here, Haley. And these are all the questions that have been submitted so far. And it looks like it's a close one between Breasticles and Crazy Run Fam. Let's see who the next question is. I love gambling. And apparently the world does
So
too.
do I.
It's like the rain bet of like tutoring. Crazy Run Fam, it's you. All right, let's do Crazy Run Fam. Let's see what Crazy Run Fam has for me today. Oh, a beautiful integral. Okay, great. Drew Taylor's
I
like,
love
oh, come
integrals.
on. Yeah, they have that website. What,
I was
integral a
upset
day or
when I saw an
something?
Integral. I think so. I have some software on my computer. I forget what it's called. It literally will just like make you
Just-
integral, derivative problems, all that.
Oh, I see. It's just kind of
I
like a
got it from
training
my
ground.
old my high school calc teacher. She was like, yeah, if you ever need extra questions to study, just come up to me. I got a software and it'll just make you a worksheet of problems. It'll give me solutions, all that.
You're getting in
So
your math
that's cool,
reps.
and I
That's
downloaded it.
dope. That's dope. Okay. How do we do this one though? What, e to the 3x?
I'm like master at integral. I've been teaching so much calculus this semester. I'm like back to
Yeah.
being good at integrals. I was so bad a month
Yeah.
ago.
Teaching it will make you great at things. Tutoring is like the
Yeah.
number one reason I got better at math, because I just had to teach it. Jeff says it's ugly. It involves arc hyperbolic functions.
Oh wait, no. I think you can. 1 second.
Yeah, I think I'm with Jeff. I don't know if. I mean, that would be the first place I would go. Usually, if you see
I usually want
square
something like
root-
this, right? Like 1 plus tangent squared of something, because then I can just get square root of secant squared, and then
I think
I'm
you
just
can do
doing
this with
secant.
Yeah, you get
Tricky
something like
you.
that for trig, but with hyperbolic trig, you get you can expand it into terms of your exponentials. So you'd probably want something like that.
Joseph's like,
do a U substitution.
JC says set
Yeah,
the whole
you
thing
can
equal
do
to
U.
U? Wait, what? Is that real?
Yeah, I actually agree with that. I feel like that would work.
Okay, 1 plus e to the 3x is equal to u. So what? du is equal to 3e to the 3x?
Yeah.
du?
Du.
Or
yeah.
dx, sorry. Okay.
Dx.
All right, so now we're
But then-
gonna do that. So what? That's u to the 1/2, right?
Mhm.
Over 3e to the 3x. Oh, which that's probably related to this somehow, right?
Yeah.
Yeah, it would just be E
U minus 1?
1/3.
Yeah.
U minus 1 over 3, right?
U minus
'Cause we
1
need-
over 3.
No,
Yeah.
No,
sorry,
you could just do
3
U
3u
minus
minus 3. Well, it's okay. First of all, let's just pull the 3 out, right?
Yeah, that's what he's saying.
Okay, and then e to the 3x is just u minus 1.
Yeah.
Oh, beautiful. JC wasn't trolling. Okay, cool, nice.
Yeah. And I think you can do another substitution.
We're gonna do v
I
substitution.
wouldn't do any substitution.
Ooh, no substitution. Okay.
Actually, no. Yes, sorry. I flipped the fraction upside down in my brain.
Yeah. I think
Mm,
you do another
Go on
substitution, which
insane.
seems useless, but it works.
do I say like u minus 1 is equal to v?
Yeah.
Okay.
Du
So then
is dv.
du is equal to dv.
Yeah, it's just so that you can get a separate.
So you can get rid of this shit, right? Yeah. Okay.
Yeah.
So then that's 1/3 integral of v plus 1 to the 1/2, right?
Yeah.
All over v, and then dv. Okay. Oh, I see. Because then I'm gonna bring this thing inside. Okay. So then that's 1/3 integral of 1 over v to the 1/2. Wait, can I do that? Fuck. No. Sorry. If I have
It'd be
square root of v
1
plus
plus-
1 over v, yeah, I can bring this inside, right?
Yeah. It would be 1 over. It would be 1 over v plus 1 over v squared. I don't think it would work out well.
Yeah, I don't think that works out well. I'd rather you do u equals v squared. Okay, let's go do that. Let's go do that instead. I think that's a good idea, JC. And then do partial fractions. Ooh. I like partial fractions. Yeah,
Yeah.
fuck up some partial fractions. All right, so if u equals v squared, then du is equal to
minus
2v
1, I
dv. No, I think he wants to leave it here, so then we get v minus 1, v plus 1, and do partial fractions.
Oh, yeah. Okay.
Because watch, because then you get 1/3. It's actually really clever. This is integral of so u the 1/2 would just
yeah,
be
that's
v.
nicer.
Yeah, this is beautiful. And then this is v squared minus 1, and then this is 1 over. All right, no, sorry. But then du is equal. So then this is 2v dv for this.
Yeah.
Okay. So now we have 1/3 integral of 2v squared dv over v squared minus 1.
Yeah.
So then let's split
Okay.
that.
Yeah. Before you split it, because like the order of the numerator and the denominator is the same,
Mm-hmm.
you can write that as v squared minus 1 plus 1.
Oh, okay. Let's do that. Okay. So I see. So you want me to write this as v squared minus 1 plus 1
Yeah,
all
that-
over v squared minus 1?
Yeah. And that gives you 1 plus 1 over v squared minus 1.
Ooh. Oh, yeah, okay. This is cool. That's actually a really unique trick. Right. This is 1 plus 1 over v squared minus 1 dv. Yeah?
Yeah. And then you can do the v
Oh, that's
squared.
that's beautiful. Yeah, because otherwise I was going to have to deal with this v squared. That would have sucked.
Yeah.
Oh, I didn't know that. That's a really cool trick. Okay. This
I
is partial
think-
fractions.
Is it 1?
That's a hyperbolic trig.
Oh, yeah, actually,
You
wait,
can
we
just
don't
go
need to do
straight-
partial
that's a,
fractions.
Inverse hyperbolic trig. I
Yeah,
wanna
which
say
one
it's,
is that?
Inverse
Arc sine?
hyperbolic
Arc secant?
arctangent.
Secch?
I want to say that's hyperbolic arctangent. If
I think it is also a lawn thing, isn't it not?
Yeah, it's in ln, but it's an ln because it's a hyperbolic term.
I think you actually get a cool identity from this also if you do it 2 different ways, I think.
Sorry, what did I want? I want 1 over something squared
V
minus 7
squared
squared.
minus 1.
Yeah, where the
Or
fuck is
x
that?
squared minus 1.
Is it? I don't
You
see
could
any
use Wolfram, honestly. Just to see what
I could use
is.
Wolfram. Wait, no, here we go. Found it. Blessed Wikipedia.
Oh,
Wikipedia is-
arctangent.
Wikipedia is like using WebMD to like diagnose whether you're sick. You're just gonna like, oh, I have cancer.
Well, I don't think you got it.
Did I get this
Yep.
one? No. Shit. How did I not
No,
get it?
that's A squared minus 1, which is, I mean, technically it's right because you can factor out a
Wait,
negative.
Wait, can't you just can't you just flip this? Is this just negative arc coth?
Yeah.
Wha-
Yeah,
Right?
but you
Wait,
can also just do a partial fraction and get a lawn, which is like actually an identity.
Oh. Lawn. What the hell is lawn?
ln.
Oh, ln. Oh,
Sorry.
you guys call it lawn? Wait, what? Did lawn? What the fuck is lawn? Lawn is something I have to mow. Well, here's the interesting thing. So it says when u squared is greater than a squared. How do I know whether v squared is greater than a squared?
Bounds of the integral.
But we don't have bounds.
That's why
It's
the
unbounded.
ln. That's
You
why
just you would
ln
just
works
use the
better.
domain of the function, so that would.
Well, we said u is equal to v squared. V could be whatever. Oh, u is 1 plus e to the 3 to the x. So this will always have to be greater than 1. U will always have to be greater than 1, right?
No, greater than 0, right?
No, 1, right? Because this
X goes to negative infinity.
if x goes to
Oh,
negative
wait,
infinity,
what am I thinking?
this
Yeah,
goes to 0,
sure.
right?
Okay,
So
yes,
u
sorry.
is always greater than 1. If u is always greater than 1, then v is most definitely always greater than 1. So I want to use the coth one, I think.
U squared, yeah.
Right? Because u squared is always greater than a squared. Okay. So this is negative 1 arc coth. Yeah, exactly. Crazy, right? Yeah. Arc coth of, oh man, v. Just arc coth of v. We cool with that? I think we're cool with that. And then this is just v. And then there's a big 2/3 out front of everything. And then technically there's a plus c. I'll just put a plus c at the end, right? Can I just do that? No, anybody get mad at me for that? Okay. And then v is equal to the square root of u. So then this is 2/3 square root of u minus the arc coth of square root of u. And then finally u is equal to 1 plus e to the 3x. Equals 1 plus e to the 3x. So you get 2/3, sorry, times all this. 1 plus e to the 3x to the 1/2. Yes, thank you, JC. I was not practicing safe parentheses.
The ln identity would also give something nice.
Show me, which one's the ln identity?
You just do partial fractions and you get like 1 minus.
Yeah, well, so the definition with the ln is the actual functional definition of the inverse.
Oh, for this.
Hyperbolic cotangent. Yeah, so they're completely equivalent. You could either
Yeah.
do partial fractions there, or you could go through the hyperbolic trig sub to get that, and then you could just take that functional definition of the hyperbolic arc cotangent and get the same result.
Now,
Yeah, there should be
I
a
sh-
1/2 also.
I should know this one, right? 1 over x squared minus 1. I know that's 1 over... Is that 1 over x plus 1 minus 1 over x minus 1? Is that how that one works?
It's
This is... I feel like this is like something on a math competition you should just know.
I think it's 1/2 the whole thing.
Okay.
Because you do the common denominator, you get x minus 1.
Uh-huh.
Oh, sorry, I think it should be the other way.
Okay.
X minus 1.
Because this would become x, sorry, and then this is minus, right?
Yeah,
This would
x
be
plus 1.
X plus 1, right? Minus x plus 1. Okay, good. Yeah, and that would get you 2.
Yeah.
But then you need the 1/2.
Yeah.
Got you. Okay. And then that gets you your LNs, right? Because then that's
Your
lawns. We beat you in hockey. It's called LN now. Can't say lawn anymore, dog.
That's what it was for. That was the real price.
It was really just for hockey, dude. That's all it was for. Okay. ln of x minus 1 minus...
I mean, US finally had to win a game in like, what, how many?
40 years or something, dude. It was nuts. Yeah. I stayed awake all night, actually. I was leaving the warehouse at like 4 a.m. and like some chick like DM'd me being like, oh, hey, I'm waking up. Do you want to go to the bar and go watch this game? I was like, what time's it at? And they're like, 5. I just stayed up for it. Yeah, I just stayed up. I just stayed up till like 10 a.m. to like watch that game.
Yeah, okay. Well, I guess who's worse?
It was the first game I've ever watched of hockey, too.
Oh,
okay.
Wait, that actually?
The game I watched?
Were you following the puck at all?
I was asking the person next to me like how the game works. I was like, I know they try to put it in the goal, but like I didn't understand the whole like power play, and then there's like offsides, and then there's like kill.
Yeah.
There's all this weird stuff. I was like, oh, pretty cool. What's up, Reki? Okay, so this is what this becomes, right? Yeah. Long time no see. Yeah, good to see you, Reki.
They are the same though. It is.
This is the same as this hot garbage.
Yeah. Yeah.
Yeah.
Oh, that's cool.
The only thing is, Wolfram says it should be the just a normal hyperbolic arctangent, not the cotangent.
Oh, okay.
So probably just something with the A.
Well, okay, wait. I think the arctangent thing, that comes into this definition though, right? Of whether u squared is less than a squared or u squared is greater than a squared.
Yeah.
Did you give it all of this stuff as well? Did it understand that u has to be greater than 1?
Yeah. Well,
yeah. Well, they did a different substitution for u. They did. Yeah, u equals 3x, and then, u equals e to the 3x.
Mm-hmm.
And then when you do the substitutions, you get p squared over p squared minus 1.
Yeah. Okay. Yeah, that's what we had here. That's what we had.
Yeah. Everything else, they just use the.
Not being. Sorry.
What about bounds? Okay. I think it's pretty close.
No, I was saying that.
Yeah, I think it's close.
Bounds.
There are no bounds.
If the bounds are like not. Yeah, that's what I'm saying. If the bounds are not given, it's usually kind of hard.
I think we just suppose that x could be anything from negative infinity to infinity. Juan says, best advice for really nailing a washer method. I know how to set it up, but I refuse to use the calculator. What do you mean? Like you refuse to do the integral? Oh, to do the integrals? Oh, yeah. Sometimes the shell method is easier for making nice integrals. Let's see what they had here. Oh, okay. Yeah. This is what chat had, which I think is very close to what we had. It's basically the same thing, right?
Yeah, I think so.
Yeah. Because then, yeah, we would have gotten the 2/3 times the 1/2, which would have gotten 1/3, and then that's v minus 1 v. Okay, cool. This is great. All right, done. Juan says, I'm being taught to set up the integral and then just plug it in the calculator. Yeah, the reason you're being taught that, Juan, you want to manually integrate. Yeah, well, sometimes the integrals are fucking nasty though.
Disqualified.
That's why you just put it in the calculator.
If it's AP count, they usually give you like really shitty values to work with. That's why,
Yeah.
like, when I took AP, they just want us to set it up and plug it in because you get some crazy bullshit number with like 500,000 values of fractions. Like,
JC says because you're an engineer. That's fucking why. JC's unhinged, dude. 1/3 x to the third. Yeah, that's an easy integral to do. So Juan, if you want to submit an example of a washer question you need help with, I can show you whether the washer or the shell method would produce a nicer integral to do. I can show you like a strategy for that, but you got to give me an example of one. Give me an example of one that like sucks. I'll see if I can find something that's better. This was who's this? Crazy Fun? Who we do? Yeah. Oh, this is Crazy Fun. Yeah, this was kind of crazy fun. Drew says, "What is plus C? C is a constant." I ignore it all the time. But okay, cool. Good job, Crazy Fun. I enjoyed that. We're gonna go put that in our Discord. Also, anytime you put things in the anytime your question gets submitted, there's also a cute little link here that shows like directly on YouTube at what timestamp we did it, minus an ad showing or something. Yeah.
Wait, it takes a video of this and then puts it on YouTube?
So we're streaming on YouTube right now, right?
Okay, so they put a timestamp. Okay. Sorry.
Right, the URL it's streaming on becomes the same URL when it posts the recording. So then I just have the bot figure out, based on when the stream started and based on when I submitted the question, what the T equals should be for the URL.
That is clean.
Yeah, is it kind of clean? Again, vibe coding.
Wait, you like coded this?
Oh, I coded all this shit. Yeah, all this shit is mine. Yeah.
To integrate it into YouTube or integrate it into Discord?
Yeah.
Oh, that's okay.
Yeah, I just used Claude
That's
and
cool.
Claude and whatever. Yeah, dude, it's crazy.
If you don't mind, I may sometimes ask.
Yeah, if you want if you want the repo for it, I'm gonna put it on GitHub.
Okay.
Okay, let's go to the queue. 8 questions in the queue. Lots of fun questions here so far. The timestamp is dope, bro. You're innovating like any every day. Thank you. I don't know, I'm just in the shower sometimes and like bored and things come to my head and I'm just like, oh, that would be cool. And in the past, I would like just put that off because I'd say this is way too hard. There's no way I'm gonna fucking code this in like an afternoon. But now with AI, if I have an idea, I can get it coded in a couple hours and it's great. And it works. Sick. Okay.
I coded an entire semester's worth of project in like 3 hours hungover before I had to do a presentation on it one time. All using AI.
All using AI. All right, Gamer Jam. Dan Breskels, you keep barely missing it, but there we go. Gamer Jam.
Mine's gonna take a minute anyway.
He's like, yeah, yours is pain. Oh, is this one of these, dude? If I have to draw an auxiliary line, I'm gonna kill somebody.
You done messed up, Aaron!
Don't make me draw auxiliary lines.
You hate auxiliary lines.
I fucking hate auxiliary lines, dude. Like, just put them on the diagram, bro. I don't want them. No, wait, where's that question? Damn it. Copy image. Bum, bum, bum. Okay, here we go. Figure out x. X is the angle. This is symmetric to this. Okay. Oh, geometry. I don't think this angle. Well, I know there's like rules in different shapes where like the opposite angles add up to something or something else. That third angle is 180 minus 70 minus 35. Oh, yes. Correct. Thank you, Jeff. Yeah, this is a triangle. Yeah, this right here do be a triangle. And triangles all add up to 180 degrees. So this plus whatever this is have to all add up to 180. So that's going to be equal to 75. There we go. I know the other property is that all of these angles have to add up to 360, right? Like this, 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 and this have to be 360 because it's a quad god. So 70 plus 60. I'm going to call this angle Y. I don't know what this angle is. And I see. We're just going to get systems of equations.
Kidding? I think you might have to draw an auxiliary line.
I'm not drawing a line. Not doing it.
I think you might have to do it.
I don't fucking think I need to. No. No. Because look at this. Okay, so this is my total angles is equal to 360. But additionally, we also have a triangle here.
Yeah, but that's like gonna give you the same equation.
Is it? Damn it.
Yeah, because you have it 180. That's just 180 already added on one side.
That's redundant information, sadly. Is it redundant though? Yeah.
Yeah.
Oh, because this is 100
into this.
Yeah, you're right. Damn. Okay. I really don't want to draw on. I don't want to do it. I don't want to do it, Rampton. Draw an auxiliary line. Fuck.
Because I wonder if you do draw one from the 70-degree angle up to the one that you don't have.
Okay.
Are those triangles similar?
360 minus 180 equals x plus y plus 25 line time. Yeah, x plus y equals
coordinate system.
45, 205. Coordinate system? No.
Coordinate system wouldn't work because we don't have the lengths. I feel like.
Yeah, we don't have any of the lengths.
Maybe it does.
You're saying if I split this, right? Wait, actually, do I know that that splits this though? No, because it doesn't split these.
Yeah, I don't think that's. But I think if you draw it, is there two similar triangles, or two congruent triangles?
Sorry, are you saying if I draw this one?
Yeah.
Oh, okay. Wait. Because same side.
Another side down.
This is the same side. Yeah, they share this side, but then I need to prove that this angle is like equal to this angle. Okay, JC says draw a line from the top left corner to the bottom line to make an isosceles. From the top left corner to the bottom line to... Okay, what's isosceles here though? Not vertically down. Okay. Wait, to top left corner to bottom line.
Mm-hmm.
What? Sorry, what's the bottom line?
Down and slightly to the right.
Oh, like right here?
Yeah, something like that. Yeah, and then make it so that that side is equivalent to the other side.
Oh, okay.
And then the angles would also be the same.
So you want this to equal this?
Yeah, which is
Oh, which also equals this. Oh,
that's
okay.
technically the isosceles part. Yeah.
Okay. Oh, I see. Okay, so then this is 70 as well. So then, that thing is 40. Oh, so that's 35. Oh, wait a minute. But then this is also isosceles, no? Doesn't this equal this?
No, the angle, it would be 50, not 40.
Oh, did I fuck up my math? Damn. Okay, sorry.
Oh, no, I messed up mine. It is
no,
40.
This is 40, right? Yeah, so then...
Yeah, that's 40. I was
Oh, man, dude. He's coming out, dude. Alright, this
what
right here...
What the fuck is this piece of shit?
This is 35 degrees. So now this is another isosceles. Another one. Okay, great. We're slowly getting... Oh, wait a minute. This whole bitch must be like a trap or something, right? Like, isn't this angle just going to equal this angle?
That angle would be 110.
Yeah. But look at this. Like, same 110. Can I say that this is equal to this?
I don't think they are because that other triangle is a 25-degree one. This one's 235.
No, you're right. Because then if this was 110, this would also have to be 25.
You could draw a perpendicular line coming off that center line.
Wait, we're drawing another line?
Y. Well, so if you draw a perpendicular line that goes to Y, that's perpendicular to that like center line. See what I'm saying? So you have two right triangles, and you could just
Like this?
evaluate for Y. Yeah.
Okay. Oh, I say this is 90 and this is 90?
Mm-hmm.
Okay. So, I see. So what? This part is then 65? For this one?
Yeah.
Wait. Yes, 65. And then, man, what is this? Well, this is 90 minus X. Right? Join that bottom point to the top right corner. Wait, JC's saying, well, maybe we should start doing this now. There's way too many lines. I wanted no lines drawn here. Now we've drawn 3. Let's see. JSnat says opposite angle properties is my go-to here. If X is 35, Y is 120. If X is 35, Y is 120, and you have 180. You have a parallelogram with 3 of the known 4 angles. Do you see it? Okay, I see that I have this angle. Wait. If X is... How do I know X is 35, by the way? Sorry. I don't think I know X is equal to 35. Actually, wait. If X is 35, Y is 120? Sorry, JHNat, how do I know that X is equal to 35? X is not equal to 35.
That's dope.
Okay. Apparently not. X is equal to 25. How do we know X is equal to 25? X is also not 25.
Bruh.
Okay, so we're getting opposing comments. Alright, I think we're gonna get this. Unless this is like some JEE question that has like a 30-minute solution in it. It looks easy though. It shouldn't be that bad. Trust. Okay, draw that line. JC, what line am I drawing? Bottom point to the top right corner. Okay, JC wants to draw this. You can prove that is equilateral. Huh. Maybe, sorry, let me get rid of this stuff. I don't think this stuff is relevant. There could only be 2 lines. I'm not going to put 3.
Oh, yes, he's right. That's technically an isosceles triangle.
Why?
Because the 2... Oh, wait, no. Where did the blue one come from?
The blue what?
Oh no, I see what he's saying.
Oh no, yeah.
Because you have the same length and the same angle on both sides of the triangle. See what I'm saying? See, because on the right side it's the same length. On the left side it's the same length. 70 degrees, which means that the upper angle's got to be the same. And then this triangle in the center would be an isosceles.
Wait,
I think I see.
Equilateral.
Sorry,
here's my question. Why are those 2 sides equal to each other? Where did that even come from?
Where did what come from? Sorry, this and this side being equal?
Yeah. Oh, because of the 35 degrees. Yeah, sorry.
Yeah, so when we created this, right? 35, 35, that means that this is congruent to this.
Yeah, and that makes sense.
Okay, so let me get the 70 part. Let me make sure this makes sense. So here I have 2 congruent sides and a 70.
60.
Sorry, that's 60 actually. Sorry, sorry. Where's the 70 coming from? Sorry.
No, that's supposed to be 60.
Yeah,
Oh.
it is 60.
Oh,
It
oh,
is
sorry.
60.
This is 60.
Yeah.
Okay. Where's the other
then-
60?
The other two sides of this triangle, they have to be equal to
Oh,
each
they're the
other.
same.
Two angles first. Yeah.
Yes. Okay, so this has to be 60. This has to be 60. So then
Yeah.
this must be equilateral. Oh, bingo, bango. Okay, cool. Okay, so then. Oh man, we found
Then
so
you
many.
get that one. This half of the y is 60, right?
This is 60. I get that this
Yeah.
is
That's
60.
Yeah, and then the bottom one is also 60.
That's 60. Okay, so 60
Yeah.
and 70, or that's 60 is
Yeah,
130. So this is 50.
50. Yeah, and then that's also isosceles.
Uh-huh. So then this and this. So we have another equation.
Cool.
Dude, let's just write out this other
But
equation.
we also know what they need to be. They would be
35 plus x plus
60
y
each,
has
or
to
70.
equal to 130, right?
30.
35 and x plus y
Yes. Yeah.
has to equal to 130. So then I think these are two different angles. These are two different equations I can
But
use.
we
right?
also know why though.
We do know why?
Because because this is an isosceles triangle. This half of y has to be half of 130, so it's 65.
Oh. Got you.
Because y is also equals to x plus 35.
Yeah, sorry. Actually, sorry.
Yeah.
Y was the whole angle earlier. That's
Yeah.
the part I'm messing up on. Sorry. This is different.
Yeah.
I see.
If we call that z.
So, yeah, let's call that Z. Okay. So, Z is equal to X plus 35, but also X plus 35 plus Z has to equal 130. I think I got it. Okay, so then X plus 35 plus X plus 35 equals 130. 2X is equal to 60. X equals 30 degrees. Yes! We did it. Go all off. Go.
This is the biggest team effort question I've ever seen. From no auxiliary line to two auxiliary.
Yeah, there's way too many
Geometry
auxiliary lines.
reminds me why I stick to integrals. Integrals and differential equations.
Oh my god, this question. Yeah, dude, this is the hilarious thing. JC's the OChem guy. Thank you, JC.
Honestly,
Ram-
organic
I'm-
chemistry know their angles.
They do. Yeah, you guys do know your angles. Yeah, right? That's all the geometric whatever molecular shape shit. Yeah. Oh my god. Whose question was this? Gamer Jam. I swore I wasn't going to draw an auxiliary line, and then I drew two.
I really want to look at the question from
Breasticles. Breasticles had some fun one. We did gamma functions and beta functions, or like I kind of avoided it, but
It was still fun either way.
it was still
It
fun.
was a pretty fun one.
JC loves
I think
Tetris.
this question is supposed to be a calculus of variation question.
Mine or
Yes.
yeah, it has some. It's there's actually like 4 or 5 parts on top of the 2 parts that I put, but I was like that would take like way too long.
All right, let's spin.
Okay.
Let's see.
Well,
Talk about.
post the full thing and then tag me in it if you can.
Well, we're doing his right now.
'Cause then-
Yeah. Okay, that's what we're doing.
You won, Breasticles.
Oh,
Yeah.
Hard
God,
work
okay.
and lots of time pays off. All right, here we go. All
Yes, it does.
right. Oh my god, what's going on here?
It's mostly physics, so
Yes, Drew, I got you,
I'm
Drew.
familiar.
Drew, wait, Drew, what was your name, Drew? Drew, is your name Gamer Jam? Is that yours, Drew? JC says, what the fuck is this shit?
Oh, no.
No. Coral! Okay, good job, Drew, by the way.
No.
Okay, let's see.
Okay.
I got you. All right. The brachistochrone. You're welcome,
Yeah.
Drew.
So, do you want me to kind of fill you in quickly about what a
fill me in.
brachistochrone is?
Yeah, what is a
So
brachistochrone?
imagine you have like a, so draw a line. Draw like a horizontal line.
I'm scarred from drawing auxiliary lines right now, dude. I really don't want to.
No worries. This is one line.
Don't
This is-
worry,
this-
it's not an auxiliary line.
I don't want to draw any more lines.
No, that's fine. And then draw a circle on the left end, like just draw a circle somewhere, and then place it so that the center of the circle would be like somewhere on the line.
Okay.
Yeah. And then so like mark the center. Yeah. And then mark the very top point. Just at this instant. Okay. Now imagine this rolling with some velocity on where the center is like attached to.
Oh.
Yeah, and then think about the path that the top thing traces. It kind of does like an epicircle. Yeah.
Like at this?
Yeah.
I imagine,
It's
right?
it's a lot more stretched out. I think because that point doesn't move along the circle, right?
Oh,
yeah, it's kind of
you're right.
forward.
I see. This is also like going forward, so it's kind of like.
Yeah,
Uh-huh.
yeah, and then it kind of loops on itself too. Yeah, but
Yeah.
a small
Oh.
loop. Yeah, yeah.
Oh.
And then the solution to this is called the brachistochrone, which comes from calculus of variation.
Oh, okay.
This was one of my favorite classes I took.
I'm glad. This is gonna be your favorite question then.
Oh, this is gonna be a rough question, but hopefully.
Okay, we'll give it a solid like 20
It's
minutes.
a challenge book.
Yeah, it is a
Very
challenge.
question.
We'll give it a solid try. Okay. Imagine a tiny bead of mass M with a wire threaded through a hole, allowing the bead to slide without friction along the wire. The wire lies along. And the other end of the horizontal. The only force. Inverse square gravitational force due to a point mass M located at the origin. Okay. So there's no like actual gravity. It's just gravitational force between the two masses.
Yes.
Okay. What shape function r theta should the wire have to minimize the travel time of the beads as it slides from r0 to r pi over 3?
Oh, it's a boundary problem. Oh, this is good. Okay.
Okay. All right. He says it's good.
This is under the gravity of the
My
Earth.
book.
This is
Sorry. Polar coordinates. R and theta, right?
Yeah.
Okay. R0. Okay, so this is R0 then, right?
yeah.
And then we have another point at r pi over 3. It's like right up here.
That's 60, right?
Yeah.
Yeah.
About 60.
I think it's supposed to go the other way around, by the way. I think this question's wrong. Like the way you said it is backwards, I think. Like, 1 second. I want to make sure I understand this. This is like a very classic problem.
Wait. An attractive radial force towards the... Okay, so then it's... But everything's being attracted towards here?
Yeah.
Got you. What shape function r of theta should the wire have to minimize the travel time of the bead as it slides from here to here?
Oh, okay. That would...
Yeah, and it guides you.
Oh, everything goes towards the
Yeah,
center.
this is the
it?
restoring force.
Oh, okay.
And then yeah, Breskel's is right. I think there is kind of like some guidance here with like how it works.
Yeah, that's all the each question like guides you to that bigger question, but it's says,
we're getting
fill in
getting
the
our hand held.
details of each step to
Yeah.
get to that final result.
Okay, do you want me to kind of
Yeah.
cheat you to the answer?
Yeah, cheat me to the answer.
I kind of feel like, so if this bead, like I think having somewhat what the answer should be would kind of give you a lot of guideline, I think. If I'm not mistaken, because I don't think, this is not the problem that I have done. That one's gravity is downwards, this is towards the center.
This is all towards the center. Yeah.
Yeah, but I think it's supposed to be like a, kind of like a U-shaped, where this thing doesn't, instead of drawing a straight line from,
It's not going to do this, obviously.
yeah, it's not going to do that. Yeah.
Does it
It's
have to
gonna
do
be
something
more
like this,
a-
maybe?
Yeah, I think the other way around, towards
Or you
the
think
center.
this?
Yeah, because that's where the gravity is. You can kind of tilt your head and pretend that the floor is towards that direction. What would it do?
Oh, I see. Yes. Okay. Like, yeah,
like
okay.
If you tilt your head 90 degrees.
Yeah. If this is the
If it was
ground
to
and I'm like standing up here,
Yeah.
then this would look like it does this.
Yeah.
Yeah, I think, and it's asking what shape should the wire have, not what shape would the, like a point on the circle have. It's saying like what
Yeah.
shape should the wire take to minimize the speed that bead would need to
Yeah.
roll there.
And the solution to that is the Birkus-Lagrange, which is using the Euler-Lagrangian part B.
Wow. Okay, let's do part A.
Yeah.
And then I'll feel good about
I think-
myself. The bead has an initial speed that there's an attractive radial force. Show that the initial potential energy of the bead is equal to negative GMM over R. Okay. So, I mean, potential energy, you have to define some potential to be 0, right? So we define that like potential 0 all the way at R equals infinity. Yeah.
I think this one wants to use the conservative force definition.
Oh, okay.
So force is the negative gradient of potential.
Yes. Okay. I agree with that too.
Yeah. And then from that, you can derive the potential. Because your
Okay.
force is given.
Yeah, our force is given as gm little m over r squared, and that's equal to negative d dr, right?
Of U.
Of
Yeah.
u. So then put on both sides, right? G big M little m over r squared is equal to negative du, integrate. And then I think you do have to define where potential is 0, right? I think you say potential is 0
Yeah.
at r equals infinity, and then it's equal to a potential of u at r equals r, or r
To be
equals
honest,
a maybe.
you don't even have to assume that it's infinity. But yeah, for this one you do.
Usually you want to set some.
Yeah. But I was
So
just saying, like, as a fun fact, if you don't
Yeah.
turn it into infinity, and you would say that the potential should be like non-zero at infinity, then you would enter the realm of gauge theory.
Oh dear.
Because potential is not technically measurable, right?
Sure. It's just
and
relative.
So it's just relative, right? And like, as long as the negative gradient of your potential is the force, you can always adjust your potential to be anything you want, as long as its gradient becomes the force, because force is measurable.
Okay, so I get gmm over r is equal to u, but I think they wanted a minus sign on it.
Yeah, because I think you.
We're not
Well,
using
if
minus
we
sign.
say that, because there's no friction, energy should be conserved. So you would say that your sum of your kinetic and your potential is 0.
Okay, sure. Well, I
Or
agree
sorry,
that one.
your potential minus your kinetic is 0.
Okay. I see. I mean, so far how I got it was potential is, Okay. You're saying
I
the total
think your
energy is equal to 0.
bounds-
I think my bounds are okay though.
Your
No.
bounds might be off. That's the. I'm trying to.
So I went from infinity to A, which is the same as going from 0 potential to U potential, right? Oh, you know what it is? Sorry. This points in the negative r hat direction. That's why.
Yeah.
Oh yeah.
That's what it is.
Yeah.
Okay, got it. This is positive minus. Okay,
Yeah.
cool. All right. We showed that.
Okay.
Great.
There we go.
And then we know that the kinetic energy, the initial kinetic energy is that so that the total energy is 0. I agree with what Bresticle said, right? Kinetic plus potential has to equal 0, so kinetic must be the opposite of potential. Okay. Great, we did part A. That wasn't so bad. Is part B where things get weird?
And then we look at part B. Yeah, I think that's probably where it does.
Oh. I felt a win from part A. If t is the total time for the bee to travel from one end, then t is equal to the integral of dt, which is equal to the integral of ds over v, where v is whoa, is it instantaneous? Speed.
So think about the definition of velocity in terms of the differential, right?
Yeah, v is ds dt.
Yeah, ds dt, where s is the arc length.
Got you.
Right, because when it travels like a non-linear path, instead of x, we just use it.
Oh, so then dt is equal to ds over v. I see. You can integrate. Yeah. Oh, that's cute.
Yeah.
Oh, cool. Nice. All right, dope. That's so weird to think of it that way. I guess it makes sense. I don't know. I've never done like ds 1 over the velocity. So that's funny. It's like backwards. In polar coordinates, ds arc length, right, is dr squared plus r d theta squared plus ds is that. Invoking conservation of energy always, because there's no friction, show that t is equal to this huge mess.
Yeah, so you just have to integrate.
Oh, we just have to integrate ds, right?
ds. Yeah.
Right, because this integral dt will just be t, but then I need to integrate ds, which is square root of dr d theta squared plus r squared d theta all over v.
Yeah, and v is dr d theta dt. I think. Wait 1 second.
Thank you, Jeff. Yeah, Jeff, you can always deny those. Those are cool.
V
all
is dr d.
And then this is all over v, right?
Yeah, but you have to write v in terms of the.
I think you would use an equation of motion at that point, because we have the initial speed and we know that the force acting on it.
What are we doing? What are we doing with all the kinetic energy stuff? I feel like we need the energy things, no? Like what was?
Oh, I see. Yeah, initial. I forgot about that. He's right. Yeah.
Okay. What's up?
So initially, remember how his kinetic energy was?
Oh, okay.
Over R?
Yes. But then that's also equal to 1/2 m and then whatever the velocity was.
V squared.
Which is 2 big G.
No, I think you would just want to do 1/2 mv squared and then solve for v.
Got you. Uh-huh. Oh, okay. Yes. That's the initial, though, no? I gotta think how that works.
No, this is always the case.
Oh, right, because KE plus PE is equal to 0, so KE is always equal to negative PE. Got it. Okay, got you.
Yeah.
Got you. Okay, so V is equal to the square root of 2 big GM over R, right? Which I think was given to us here.
Yeah.
Great.
Right.
Okay. Love that.
But, yeah.
But that was fun. I mean, cool. Okay. So then I have integral. I still have square root of dr over d theta squared plus r squared d theta. But now I have this over square root of 2 big GM over R. Right?
Yeah. Which that over R goes into the numerator.
Goes into the other one. Right.
And then the square root of 2GM gets factored out.
Yes. Okay. So we can say 1 over square root of 2gm. And then this is the square root of r dr d theta squared plus r to the third d theta. Okay.
I think so.
What am I trying to show? I'm trying to show it's eventually this. Oh. Oh,
Yeah,
that's
so
oh.
I think
Okay.
We did.
Oh, we did it. Wait, when does this problem get
And then-
evil?
So,
probably in the let me check the book. Let me see when it gets bad.
When does it get
so
bad? This
here's
is-
here's what it would say next, right? So r is a function of theta, right?
Oh,
but-
we want r of theta. The whole goal at the end of the day, right, is to find r of
Yeah.
theta to minimize t. Oh, so we're
Yeah,
gonna take the
exactly.
derivative of this. Yeah.
No. So this is a derivative because when you're talking about the r is a function of theta, right?
What's up, Visible? R is a function of theta. I agree, because that's the path.
Yeah.
Yeah.
Yeah. Now, because it's a function of theta, but we don't know what r is, right? Relative to theta.
Yeah, I just sent you the rest of the
Okay.
question.
Where
Oh
is it?
Jesus! There's a lot of here. You put it in my chat. Here, I'll post it. Here you go. This
Yeah.
is cool. So, because this is t, right? And our goal here is to minimize this.
It was the top. Yeah.
So.
This is called your functional, by the way.
Uh-huh.
So a functional is like a function, which is your t, where that function is in terms of a variable that is also in terms of another variable. So
Oh man.
in time is in terms of r, which we don't know how it relates to theta, and r is a function of theta.
Okay. And so then we're gonna do some
Okay,
fancy
and then-
Lagrange stuff.
Yeah. And so Euler-Lagrange said that how can we minimize this? And it is through taking what your integrand is and using that on
Oh, this is yes. This is from Lagrangian Hamiltonian physics stuff.
exactly. Yeah.
Oh. Apparently Euler knew this, and he wrote to Lagrange as a teenager. What?
No, teenage Lagrange.
Oh,
Yeah,
he wrote.
Lagrange was a
Oh, Lagrange was a teenager. Damn.
Oh, wait. That is he was a crack teenager. Okay.
Yeah, he was cracked, dude. What?
Good job.
Damn, bro. Okay. This is cool. Let's maybe like stop here because this was fun. And then we could do the rest of this on another stream because I think this would be fun. I would be down to go through this and like learn this.
If you ever want me to kind of just walk you through the math of the calculus of variation, I can just do it one time. I
Yeah.
feel like you're pretty good at calculus, so it's just the knowledge. I feel like you'll like
I know
you
I've
can
done it in
crash
like
course it.
yeah because now I understand all like the parts of it and stuff. And wait, Brescos, remind us, are you self-teaching yourself doing this stuff? Is that what you're doing?
I'm self-teaching it, but I'm also in school for math, computer science, and physics right now. So
That's sick that you just like want to like figure this shit out yourself. Dude. That's dope.
yeah, I just think it's fun.
Okay.
I think it's cool too.
Yeah, breasticles. This is breasticles.
You have to call him breasticles. He's been through a
yeah,
car accident. We have to
but-
call him breasticles.
This is actually a very common problem. I've never seen it with gravity, but I've seen. I mean, this is kind of a cool variation.
Yeah, I've worked
kind of
through
like
through some similar questions, but I saw this one and I was like, "That's really cool. I wanna try to do that."
Yeah. Nice. Okay, we'll try and do it. We'll do the next part during the one. Cool question, Breasticles. I appreciate it. Let's see what else is on the. A lot of people in the queue now. This is great. Lucky. I love. Someone told me to add this, to add the whole like how many minutes people have been waiting. So I can kind of get an idea. So Lucky Cat has been waiting for an hour and 20 minutes. Juan has been waiting for 36 minutes. You found us on TikTok. What's up, Juan? Let's see, Juan. If Juan, also a reminder, if you want to increase your chance, Juan, of your question getting answered, every 3 minutes you can hit this little upvote button, and it should boost it for you. See? Yeah, look. See, now yours is up here. Look at the power of just doing one upvote. But then you have to wait every 3 minutes for that. All right. Let's go choose a winner. Gambling. Graph for this. Okay, graph for this. You're the next winner. Waited 69 minutes.
Nice.
Good job. This might be an easy one. Oh, Jesus. What's all this stuff, dude? What do you want to do with all this? Twice Lamau. All right, let's see. Oh. That means I'm bad at gambling. Yeah, don't get... You know who's good at gambling is Ibby. Ibby had a 2.7% chance yesterday, and she won it. She clutched it. But it has a second page, linear regression. I do remember this also from yesterday. No, this is the whole thing. I think this was it. It said, teacher said line graphed for each. Okay. Effect of concentration on reaction rate. Oh, I see. Oh, so you just gotta graph like different things. Yeah. So in general, right, if we're saying like what's the effect of this on this, this is your dependent variable. Yeah, this is dependent, right? And then this is your independent variable. So this would be X, this would be Y, and then you can see from here, right? Concentration would be this column. Dependent variable would be reaction rate, which is this. So then if you want to graph it, this is where AI is nice, because I'm just going to grab the screenshots. A lot easier.
Oh, that is a...
Let's grab it. Say, export the concentration and the reaction rate as separate columns for an Excel graph. Okay, so wait. There are two Y's. Well, I mean, reaction rate is just 1 over reaction time, right? This is like period versus frequency, I think. Yeah. Yeah. So. There we go. Okay, great. Can I just paste this into Excel? Let's go do it. Sheets.google.com. You literally just slam this in. Oh, didn't do it correctly.
You're not that guy.
Fucking clanker. Here, do it as two separate outputs. Thank you. That's what I wanted. Good. And there you go. There's that. And then here. There you go. So once you have this is really cool. You can literally just highlight this. So let me just show you. Once you have this in Excel, or I guess in Google Docs, then log graph it. Yeah, so here you can just say insert, we want a, where's a chart? Where's the chart? Wait, what? Chart. There we go. It'll actually figure it out for you, which is actually really cool. Yeah, they use all this AI stuff now in the, so yeah, cool, that looks great. And then here, actually, I think if I change this, it changes this title. Or, there you go.
Can you do a line of best fit on this as well?
You can. Yep. So, if you go to series, trend line, You can then select. So this is probably logarithmic. Yeah, and then here's the cool thing. You can put data labels. You can put error bars on shit. Here, and then let's just... here, can I use the equation? There you go. So there you go. So what used to take probably like 30 minutes back in the day to like graph this stuff, you can do it in like 5.
Yeah, now it's
Yeah, right? Okay, cool. So here, I won't make all the other graphs because that's your homework. You should do that. But I'll at least show you like what it would have been. I trust you can do the other parts. Temperature on reaction rate. So then, same thing. This is X. This is Y. Y. So there you go. Sure, we'll just label it for you. X, Y. I know my Y's look like X's. There we go. Surface area on reaction rate. Oh, interesting. No, that's okay. Okay. Surface area. Oh, fascinating. So this will be Y, but this won't be a number. Oh, and interesting enough, they also put like the mass of it. Dude, what? What's going on here? I don't even know if this is allowed. Because you have 2 different masses of things. Oh, I don't like that.
I think
Nature.
it's because one of them is a marbled chip, CaCO3, and the other one's powdered. So I think it's like they ended up putting different masses.
Right. Yeah, because they have different densities, I guess, right? Yeah. It's just
or like they probably needed to put like the same amount, but they didn't have. Like realistically, in the lab, they wanted to both go for 1, but they couldn't get down to 1. I think.
Yeah, it's pretty. That's trash. This one, this is still Y, but this is one where I wouldn't do. I wouldn't do a scatter graph. So, for instance, this would be. What was it? With catalyst. So you can say like with catalyst. Yeah, bar graph, right? Without catalyst. Yeah. Because this is not numerical stuff. Then 4.64, 56.21. And let's see. I think the AI would be smart enough to determine that. And that's the reaction rate in seconds. They just put little s. That should be like mg per s, actually. Sorry, what? I think they're missing something here. This should be like seconds to the -1. Yeah.
Alright. If you don't mind, I might...
You're so good.
Here.
Appreciate you, Ramton. Thanks for being here.
But thank you so much for letting me crash your stream.
Thank you. No, you didn't crash, dude. Thank you for
help out.
teaching me and stuff. Yeah, you were great. We'll see you
yeah,
on...
I'll also think about some ideas.
Yes, let's do it.
Yeah.
Let's...
Yeah.
Okay. Sick.
Alright. Well, have a good day.
Say thanks to Ramton, guys. Ramton taught us. Thank you, Ramton.
Alright. Have a good day.
You too. Okay, there. This would be a bar graph. There you go. Okay. So these you can do as scatter, and then I believe these I would do as bar graphs. Yeah. Okay. Cool. I'm gonna say it's done. I'll give you the link to the Google Drive thing for it. So you can go see it.
Well done! Well done!
So that was for teacher. I'm super annoyed they changed this on Edge. You can't drag things anymore. It's so lame. And then here, let me give you the link for this. We'll call this office hours 224. 26. And then anyone with the link can view. There you go. So then your thing's in right here in the Discord. So there's a screenshot and there's the link of how to do it. All right, let's go see what else we got for questions. Lucky Cat's been hitting the votes. Longest 90 minutes ago. Let's choose a winner. Looks like it goes to Lucky Cat. Nice. Okay. The nice thing is after we do this question, everything is basically an even amount of chance. So let's go pick it up. Oh man, you want me to factor all this stuff? Okay. I'll try to do this as quickly as I can. All right. Sketch the following polynomials. Be sure to show your process. Okay. So this is not in factored form. It would be nice to put this in a factor form. Again, I always like to try to figure out, I like to guess a factor. I'm going to guess 1. And 1 does work, right? Because 3 times 1 is 3, plus 4 times 1 is 4. So 3 plus 4 is 7, and 7 minus 5 minus 2, also 0. So guess 1, yes. So now you know, you have 3x cubed plus 4x squared minus 5x minus 2 is equal to at least x minus 1 times something. You can do polynomial long division to find the other ones. To save time, I'm just going to get chat to just do this. Just factor it for me. So what was that? That was 3x to the third plus 4x squared. And then I'll show you all, there's all the multiplicity stuff, which is cool. Minus 5x minus 2. Factor. Just factor for me. Cool. Yep. Test 1. 1 works. Do division. Yep. You get a quadratic. And this is what you get. Cool. We did that last time, so I'm pretty sure Pineapple, you understand how to factor that. Okay, so once you got it factored, that's part B. So x equals 1, x equals negative 1/3, and x equals negative 2 are roots. Or zeros, yeah. Determine the y-intercept. This is a great one. So you already know that y is equal to all this. So the y-intercept is when x is equal to 0. So if you plug 0 in, you get negative 1, 1, and 2. So that gets you negative 2. So 0, negative 2 is your y-intercept. Sketch the polynomial by hand. Yep, this is cool. So here's how I sketch it. First thing I'm going to do is I'm going to put down my zeros or my roots that I found. So I know there's a root at 1. I know there's another root at negative 1/3. So let's put that there. And then I know there's another root at negative 2. And then the additional information I have here is that the y-intercept is at negative 2. So that means this is also going to be a y-intercept, right? And then because the multiplicity of all these roots, or all these factors, sorry, is 1, you see everything's to the 1 power, that means it's always going to cross. So we're not going to get any bouncing. Things are going to cross. So I like to look at the end behavior of this. So because this is an odd function, that's always kind of a key thing to determine whether it's even or odd. So this is odd because x to the third is your highest power. And it's also positive. Like the leading coefficient here, 3x cubed is positive. So that means my function is going to look something like this. So as we go to infinity on the right side, it needs to go up to positive infinity. And as we go to negative infinity on the left side, it needs to go down to negative infinity. So I know this has to happen just right off the bat. And then because it started down and this is a cross, it has to go across. And then it has to come back down to this 0. And it needs to cross, which then we know it's going to hit here. And then as it approaches the next 0, it has to come here, it has to cross. And there you go. So I think that's all it is. The x-intercept. Well, the x-intercept. What? These are all the x-intercepts. There's 3 of them. Okay, cool. Does that answer your question, Pineapple? And then I can't really sing. No, unless it's karaoke and I'm drunk and it's Lady Gaga.
Disqualified.
Then I can't sing. Okay, great. Good job, Pineapple.
Well done. Well done.
So easy to understand. Yeah, thanks, man. Yeah, if you ever want to, I have a video on this one. It's one of my more popular videos, especially on TikTok and whatever. There's videos of me singing Lady Gaga. If you go to how to factor, where is it? How to graph polynomials in factored form. Yeah, go check this video out. It's one of my top videos. But it explains how to do everything in terms of what the factors are, which are the zeros, and then what these exponents mean. These are called the multiplicities. And then, yeah, it's a cool little complete guide. I basically did it here on the stream, but this is with like more memes and sounds and fun shit. So there are videos. I do make a lot of videos. All right, let's go see. All right. So, now for the next vote, or next spin the wheel. Let's spin. Who's gonna win? I was born that way. It's Haley! Thanks for waiting, Haley. Haley had a 27.6% chance. Ooh, geez. A lot going on here. Okay. I will do some of this. I don't know if I'll do all this. Or Haley, you can tell me like what's the most confusing part of it. Approximate logarithms. These are fun. I'll just show you how to do. I'll show you how to do a couple of all of them because this is a good review of all log stuff. All right. Anytime you have all this stuff, you want to try to write whatever this is, Haley, in terms of what your base is. Okay. So, for instance, for log base, and sorry, let me do it in a better color. Black. Okay. Yeah, black's okay, right? So log base 2 of 8. I can also write 8 in terms of a power of 2. So what you should remember is 8 is the same thing as 2 to the 3rd. Right? And then here's kind of the trick. Whenever you have log base of the same number, you can actually kind of just get rid of it. This is also another log rule thing. So here you go, log rules. Again, another set of videos you should watch. If you're on TikTok especially. I have... Here we go. How to use log rules for tricky expressions. These are good. And then here we go. The 4 major rules for expanding and condensing logarithms. So if you missed logarithms and you had like a shitty teacher that didn't really teach you about logarithms, please, yeah, just go watch these 2 videos on logarithms. It's basically the main ones you need to know. But one of the important ones is if you have the log base a of b to the c, and the log of anything to an exponent, the exponent can come out front. That's how that works. Okay. So if I write 8 as 2 to the 3rd. Now I'm taking the logarithm of something to an exponent. That exponent can come out front. So then I have 3 times log base 2 of 2. And anytime you have the log base of the same thing, this is 1. So the whole answer is just 3. So, okay, cool. That one's easy. This one's not bad either, right? Because I could say, oh, this is the same thing as the log base 10 of 10 to the 2. 2 comes out front. And that's just equal to 2. Okay. Where things get a little trickier, I think, let's think how you want to do this. I think you want to split things. So, for instance, the log base 2 of 14, that's the same thing as the log base 2 of 2 times 7. You see how 2 times 7 is equal to 14? And then there's another log rule we learn, which is the log of a times b is also equal to the log of a plus the log of b. Again, this is in my video. This is another really important rule. So this is the same as the log base 2 of 2 plus the log base 2 of 7. Okay? I already know what the log base 2 of 2 is. That's just 1. And then this, well, this looks, log base 2 of 7 looks like log base 2 of 8. So I'd say, okay, cool. This is probably around 3. So the answer is probably equal to 4. Or it's a little bit less than 4. You say like, I don't know, like maybe like 3.9 or something. Yeah. Which I guess you could have also seen by basically making this 16. And then understanding that 16 is the same thing as 2 to the 4th. And then you would get the 4 out. That works as well. Kind of the same thing here, right? I don't care about 90,000. So I'm just going to say that's basically the log base 10 of 100,000. Which 100,000 is the same thing as 10 to the 5th. So then this is just equal to 5. Because the 5 would come down. Does that make sense, Haley, so far for the first part? How that works? This one, right, is approximate. Yeah. Okay, cool. Between what 2 whole numbers is the log base 2 of 24? Okay. So you got to think about, like, what are nice powers of 2 that are between 24? That's between 16 and 32. Right? So log base 2 of 16. 16 is 2 to the 4th. That's equal to 4. And then log base 2 of 32 is the same thing as 2 to the 5th. So that's equal to 5. So it's between the numbers 4 and 5. Same thing for here. This is between 10 and 100. So 1 and 2. What's up, Zim?
Good job.
Cool. There they say P of t is equal to e to the t. Here's a graph. Determine which is true or false. Is ln of y equal to t equal to this? I mean, yeah. You take the ln of both sides. Ln of y is equal to ln of e to the t. T comes out front. And then the ln of e is 1. So ln of y is equal to t. Yeah, that's true. The graph shows that the ln of 3 is about 20 days. Ln of 3. $20 days? Wait, what? What's going on here with time, dude? What? Oh, that's thousands of days. But then, wait, what? I think your teacher's messing up here.
Surprise, motherfucker.
Because this is ln of... If ln of y is equal to t, you have ln of population is equal to... It shows e to the 3 is around 20. Is equal to t. Yeah, but on this graph here, right? Where is 3? 3 is like down here. Right? And then you gotta ask yourself, like, well, what is t then? Well, t is like super small. I guess it's like 0.05, which is 1/20th maybe? And 1/20th of 1,000 is 20 days? Or 50 days? I don't know, this is kind of weird. I mean, but teachers deliberately mixing ln and e. Oh. Oh, e to the 3rd is about 20. Oh, okay. Oh, I agree with that. This is true. Yes. Right? Because it was e to the t. So e to the 3 is equal to 20. That's true. Okay, so this is false. Right? Yeah, okay. ln of 12 is around 2.5 days. 12... I think this is also false. ln of 20 is around 3. Well, yeah, that's true. If e to the 3 is 20, ln of 20 is also equal to 3. I think, Jeff, you take a look at it for a second. Okay, cool. Exponential form, this is easy. This is what they call the BAP method. So if you have log base b of p, or no, it's b of a is equal to p, then this to this is equal to this. So you say b to the p is equal to a. So this is 2 to the 3rd is equal to 8, which is true. See how 2 to the 3rd is equal to 8? Here, this would say 2 to the x is equal to 16, which x is equal to 4 then. And then this one would be, for instance, 2 to the 5th is equal to x. So there you would be like x is equal to 32. Yeah. You just take whatever here is, you raise it to this power, and you say it's equal to that. Okay. Explained by the point 8 is on the graph. Okay, so is 8 equal to log base 2 of 3? Or sorry, no, 8 is equal to x, sorry. 3 is equal to log base 2 of 8. That's true. Because 8 is the same thing as 2 to the 3rd, right? And so that's 3 log base 2 of 2, 3 equals 3. That's it. This is it in logarithmic form. If you wanted to put this in exponential form, you would say that 2 to the y is equal to x. And so if your x is equal to 8, 2 to the 3, which is y, yeah, 2 to the 3 equals 8. What is the x-intercept of this graph? There is no... Oh, the x-intercept is here, sorry. So x-intercept is where y equals 0. So you would say 0 is equal to log base 2 of x. The only way you can get the log of something equaling to 0 is if x equals 1. You can see that here, for instance. So log base 2 of x is equal to y is the same thing as 2 to the y is equal to x. And so for an x-intercept, y equals 0. And so when y is 0, 2 to the 0, that's equal to 1. Anything to the 0 power is equal to 1. When will the graph reach the line y equals 7? Probably not for a long time. 7 equals log base 2 of x. That tells you 2 to the 7th is equal to x. And so that's equal to 128. Wait, no. 2 to the 5th is 64, 256. Or is it 128? Sorry, did I fuck that up? Wait, 2 to the 5th is 32. 6 is 64. 7 is 128. I did mess it up. Yeah.
Good job.
Yes. Okay, cool. And that's 1 by right. And then solving for these. This is where you want to divide both sides by 8 first. You want to try to get whatever the thing with the exponent is by itself. That's just a general rule in algebra. So this would be 2 to the x is equal to 512 over 8. 512 over 8 is the same thing as 64. So now you have 2 to the x is equal to 64. What I like to do is I like to write this in the same base as this. So 64 is the same thing as 2 to the 6th. And now you see 2 to the x equals 2 to the 6th. Well, x equals 6 then. Do you correct the ln of 12 one? Or was the ln of 12 one wrong? Was this one right or false? Sorry. Or I guess this was true, yeah. Okay, fine. Wait, no, is it true? ln of 12 is 2.5? It's true. ln of 12. E to the what is 12? Oh, I guess it makes sense, yeah. Okay. Okay, then look at this one. So again, divide by 3. So you have 10 to the x minus 2 is equal to 300 over 3, which is equal to 100. Again, rewrite the 100. So 10 to the x minus 2 is equal to 10 to the 2. And then just equate the exponents. So x minus 2 equals 2, x equals 4. And then kind of the same thing with this one. 2 to the x is equal to 512 over 4 is 128. 128 is the same thing as 2 to the 6th. Is that what we said? 2 to the 7th? No. So then x equals 7. Cool. All right. Does that help you out there, Haley? We did it like a speed run through all this. Don't worry. I will post this whole thing we did, as well as yeah, you're very welcome. I'm gonna post a link to the recording for this as well. So if you ever want to like go back and like slow down and be like, okay, what happened there? I invite you, go join our Discord, which is the same link you use. There's a link there to join the Discord. Because then here's your question right here. And then here, I'm gonna download this real quick for you. Haley. And so then this will get dragged in. There's a solution. And then also there's a timestamp up here with the YouTube recording. And then it's automatically set to whatever time we were working on it. So you can go back and watch it after the stream ends, which will be in 20 minutes. Cool. Okay, let's go spin some more stuff. Deem Scrader looking good here. Juan upvoting here. Juan, let's give you some more votes. Okay. We're choosing a winner. Let's see what comes up. Who's it gonna be? It's DM Scrader. Sometimes the wheel picks people who did submit first. Yay, okay, let's do this. Don't worry, guys. Juan, I appreciate you waiting the TikTok. I will get to everyone's questions today. I'm gonna speed run through them. Yeah, this one should be simple. Okay, cool. You and your friends create a video. It doesn't. Does it always land in the center? Oh, yeah, maybe that is true. Oh, yeah. Yeah, that could be the animation. Based on the fuse for hours, a social media creates a function. So, okay, f of x is equal to 2. Yeah, that's what it does. It definitely does. Will your video... Okay. Yeah, we do need part 1 and part 2. Alright. Also, let me make sure. Yeah. Here, just DMs, just drop it here. I'm guessing this is also going to use logarithms, though. Let me catch up my text messages real quick. There we go. Good. We got it. You're good. I like that. This is cool. Instagram, TikTok versus YouTube. Look at this. Yeah, Sam, Justice, and Antonella created videos, and this is actually this is cool that your teacher is doing something that's like real life. Yeah. Yeah, it's like me. Yeah, I put stuff on YouTube. I put stuff on TikTok. I put stuff on Instagram. Complete the tables. Okay, cool. Will your video exceed Sam? So did we come up with? So interesting. You figured out what the different equations were, right? This one's exponential with a factor of 2. Everything starts at 10 views. So this would be y is equal to 10 times 2 to the x, right? That's the exponential. This is linear, gaining by 50. So this is going to be y is equal to 50 plus, no, sorry, y is equal to 10 plus 50x. What's up, Zim? And then this is quadratic. Ooh, a little bit harder. I don't know exactly how to figure out the quadratic of this. Kind of a mess. But anyways, okay. Will yours exceed? I mean, the answer is yes. The reason why is because this is what's called a power law. And in general, a to the x will beat out x to the a, which will beat out any sort of like linear thing. And more importantly, it's because your power, yours is going up by a factor of 2.5. This one's only going up by a factor of 2. I don't know what the equation for the quadratic is. I'd have to figure that out. Oh, 5n squared plus 10? Okay, cool. Yeah, okay. If so, explain after how many hours your video will become more viral. So you're going to have to beat out this person, I'm pretty sure. That's going to be the hardest person. So I would say 10... What was yours? 2 to the 2.5x. So 10 times 2 to the x needs equal to 2 times 2.5 to the x. Divided by 2. So you get 5. 2 to the x is equal to 2.5 to the x. You can now move this underneath. So you're going to get that 5 is equal to 2.5 over 2. All to the x, because they're both to the x power. And so then 5 is equal to 5/4 to the x. I think, right? Yeah. And now you got to solve this. So in order to solve this, you want to get the x by itself. You can take the logarithm of both sides. So I'm going to just do log of 5 is equal to log of 5/4 to the x. Now I can pull the x down. This is a log rule, just exactly what Haley was doing. So log of 5 is equal to x log of 5/4. So then x equals log of 5 over log of 5/4. Let's throw that in a calculator real quick. Okay. So log of 5 divided by log of 5/4. You get 7.21 hours.
My man.
a cool thing to check would be how many do you have at 7.25 hours, right? And we know that's 2 times 2.5. How do we get to log? I'm not on log anymore. Oh, you need log to solve this. You have to. Okay. And so at that point, so 2 times 2.5 to the 7.2. That's equal to 1483 votes or watch whatever things, views. So you want to make sure that 1483 is bigger than anything else here after 7. And it is, right? It's bigger than this. It's bigger than this. And yeah, we already showed. How about after a week? Well, YouTube isn't always exponential. So there you go. I'd be like, yes. Congrats. Nice. But it can be for sure.
Well done! Well done!
Nice. All right, let's see what we got next. JHNat, Juan Hurt, Max, and another Juan Hurt. Let's choose a winner. And Juan, it's you, dude. Funny enough, it's the one you submitted later. Well, luckily you can see it again because we do have recordings for everything. Okay, here we go. Volume of solids. Beautiful, Juan. Yeah, let's do it. I love volume of solids. Volume of revolutions. Here we go. Okay. It's better than the first one? Well, I guess the gods decided because that's why it was picked. Okay, y equals x plus 22. So that's going to be something like this. We'll say this is y is equal to x plus 22. And then you have 22 minus 10x minus x squared. So negative x squared minus 10x plus 22. Okay. Well, when x equals 0, this is equal to 22, right? Oh, so that's cool. So we already have, like, one of the points. Sorry, let me rewrite this in red. That's equal to y, right? So when x equals 0, that's here. Cool, which actually does intersect with that one. And then... let me think like how this graph works. Does it go down this way or does it go up this way? I gotta like plug in another value. Let me plug in y equals like 1. Or let me do x equals 1. If x equals 1, I get negative 1 minus 10 plus 22. Oh, that's really far down. Okay, cool. All right, so it is doing this. So it's doing this, yeah. I'm assuming it does this. I think we can actually figure out where it intersects as well, because we also have this one, right? So x plus 22 is equal to y. Whenever you have these, two equations, I want to figure out like what shape is getting bounded. I want to figure out what these intersection points are. I already know, Juan, that this one here happens at 0, 22. But I can also then, right, set these equal to each other. You think I have it flipped? How so? Yes, you do set the... yes, exactly. Yeah, so I would do negative x squared minus 10x plus 22 is equal to x plus 22, right? So the 22's cancel. Beautiful. So then when I move that over, I'm going to get that x squared is equal to 11x. or negative x squared, right, is equal to 11x. So one of these solutions is x equals 0. Minus 1 year.
Disqualified.
The other one... Wait, the minus sign makes me upset. Wait. Fuck. X plus 22. How do you get the other one, though? Oh. Yeah, okay. Oh, and then, yeah, x is equal to negative 11. I'm stupid. Dude, I was like, square root of negative 11?
Disqualified.
No. You just divide by x on both sides. You already took care of the x equals 0 solution. You know that one works. So then the other one is x is equal to negative 11. Which, that makes sense, right? This is the other solution, which is going to be negative 11 comma, I think negative 11, right? If I plug that in. Great. Okay, and we're revolving around the line y equals positive 11. So, oh man. That's like midway through here. What? How does that work? Oh, wait. Sorry, when x equals negative 11, this is equal to positive 11. Sorry. I'm even more stupid. Sorry. This is what happened when I get, like, on hour 3 of me teaching. There we go. Yes. Thank you, Raven. There we go. Beautiful. Yes, negative 11, comma 11. Okay, and then we are revolving around this line. That's the line we're revolving around, right? Is y is equal to 11? Okay, great. I think you can just do the washer method here, no? Doing shells... no, let's do the washer method. Okay. So here, I'm going to do washer. We'll do both, maybe. Maybe we'll see one that's easier. So first thing, when doing the washer method, right, this is going to be pi. And then this is going to be r outer squared minus r inner squared. And then it's d whatever. So because this is a horizontal line, this is always going to be dx. All right? Your next goal is to figure out, okay, well, what are the bounds? Like, where am I going from in terms of the x direction? Well, I'm going from negative 11 all the way to 0. Right, so this is negative 11, this is 0. And then your next thing is to figure out what r outer and r inner are. Yeah, it's revolving around the line y equals 11. So r inner is always this blue line, okay? But I need to figure out what the distance is from here to here, okay? What I know is this distance is the same thing as the y coordinate of the blue line. And that's y is equal to x plus 22. But all I want to do is I don't want this full y distance. I only want this distance, which is going to be the full y distance of the function, of the blue function, which is x plus 22 minus 11. Right? Because then this distance right here is equal to 11. No, r of x doesn't always touch the line you're revolving. No, it doesn't. We could have, for instance, we could have revolved it around here and then just had it stop here. If it doesn't touch, you get a like a complete like chord out part. This will have like a hollow center, but it will like it'll close at the top. Yeah, you'd have a hollow. Yeah. So in this case, right, our inner is going to be equal to x plus 22 minus 11, right? X plus 22 gives you the whole distance from the x-axis. But then I only want the difference, I only want the distance to the y equals 11 line. So this would be just x plus 11. Okay? And it's the same. Yes, you do have a cone. It's the same thing actually also with figuring out our outer. Here our outer is again equal to the y position of this function, which is negative x squared minus 10x plus 22, but then we have to subtract 11 because the y gives you the distance from the function to this axis, but I'm rotating around this axis, so I need whatever that distance is minus 11. No, the bottom function is not isn't the bottom function you're subtracting? No. So bottom function usually refers to like inner radius. This is what I would consider the bottom function. This is what I would consider the top function. This is the axis of rotation. We're always subtracting the distance that the axis of rotation is from the x-axis, because functions in like this form, when we have y equals, that tells us the distance from the x-axis. That tells us the distance from y equals 0. But I always want the distance from y equals 11, because that's where my axis of rotation is. Yeah, okay, cool. Right, all right, so then our outer is equal to negative x squared minus 10x plus 11. Okay, so now you just plug this in. And this is where, this is just ugly. It's ugly to do this integral. But you have negative 11 to 0. So then this would be negative x squared minus 10x plus 11 squared minus x plus 11 squared. And then you do all of this dx. So then the last part you have to do here is you have to expand. You have to expand. And then it's just doing a bunch of integrals of polynomials. You try to FOIL it out. Okay, it's not impossible. Let me think if another method would have been easier. No, it wouldn't have been. Okay. Sure. Okay, so if you want to expand this, it was x plus 22 E-Raven, but then I subtracted 11 because that's the distance from the line to the axis of rotation. Okay, but you can expand it. This is not too bad. So I like to do this. So this is negative x squared minus 10x plus 11. And then I'm going to do it like this. Negative x squared minus 10x plus 11. And then I'm just going to like do this a bunch of times. So this is x to the 4th plus 10x to the 3rd minus 11x squared. This is plus 10x to the 3rd plus 100x squared. And then minus 110x. This is minus 11x squared minus 110x. And then this is plus 121. So you get x to the 4th plus 20x cubed minus 11 plus 100 is plus 78x squared. And then you can say minus 220x and then plus 121. So that's what all of that was. This then becomes x squared plus 22x plus 121. So then you're doing all of this minus all of this. And now it's the integral from -11 to 0 pi. So that's going to be x to the 4th plus 20x cubed plus 77x squared minus 198x. Oh, then these cancel, which is nice. Okay, cool. And then this is dx. Does that make sense so far? This is kind of my trick for foiling big things. And then it's pi, -11 to 0. Well, sorry, now we integrate, right? So this is going to be x to the 5th over 5 plus 5x to the 4th plus 77 over 3x cubed minus 99x squared. Yeah. And then this is from -11 to 0. Cool thing. I don't give a fuck about the zeros because all these have x's in them, which is great. So then your final answer is pi, and then it's this minus this. So in reality, everything's going to become positive. So you get pi, and then it's 11 to the 5th over 5 minus 511 to the 4th plus 77 over 3 11 cubed, and then that's going to be plus 99 11 squared. There you go. That's it in simplest form. Okay, this is why your teacher probably just says put this in a calculator at this point, because this is just all like bullshit math. There are times, and come back to the stream when you learn the shell method, because sometimes the shell method makes, this is not a terrible integral to do, it's just tedious. But there are times where, especially if you're doing vertical axis of revolutions, when you have vertical axes of revolutions, sometimes the shell method makes things a lot easier, at least integral wise. So this is the washer method so far. I love the washer method, but I will admit that the shell method comes in clutch for vertical axes of revolution, and also when you actually have to do the integral. Okay, cool. All right, good. Well, I hope this helped you. Thanks for waiting around. Appreciate it. We're going to put this in our Discord for you. This is Swan. I'm glad you found this. So the same website you used to submit your question here, there's also a link here to our Discord. And every time we do one of your questions, they get put here into the Discord. Well, where is it? Where is your question? I literally just did it. No. Oh, I gotta mark it as done. There we go. Now it'll show up. There you go. There's ones. And there you go. That's it. Cool. So, yeah, go check it out. There's also a recording there, so you can go watch the stream back if you want. Okay, I'm unfortunately out of time. There were 3 questions left on the queue. Who did we have? This is you just working through something. JH Nat. Ooh. Beautiful linear algebra. This is what's fun. JH Nat. And then Max, what'd you have for me as well? Solve by factoring. Ugh. I could do these, Max. But I gotta go. But don't worry. Anything we don't get to will still get put in the Discord. So someone may do it at another later time. Or our ChatGPT bot will go through and solve it in a day. Okay, cool. All right, that being said, let's close out the stream. All right, thank you everyone for coming to Actual Education Office Hours. Appreciate everyone. Thanks for all the discussions. I learned a lot of things. You guys are great. Our next stream is going to be Thursday. If you ever want to figure out when we're streaming, again, the website, click here on streaming calendar. This has all the different times that we're streaming. So make sure, go check out our other friends and stuff. Zach's doing like DiffyQ tomorrow. Riemann Surfaces with Penn Center. And Math Pawn looks like he's doing some other cool stuff. Yeah, you guys are all great. Love it. Nice. All right, let's go raid someone. Also, yeah, if you're watching us on TikTok, go follow us on YouTube. Go follow us on Twitch. Twitch is great. Twitch has a nice little horizontal format The stream looks really cool. We do vertical on TikTok and YouTube because that's what the algorithm likes for you guys to find us. Like Juan, you found us today. It's because we run vertical streams as well. But the horizontal on Twitch is a lot easier to watch on like a laptop. And we also have friends we can go raid. Who are we gonna go say hi to? So many fun people DJing these days. Or DJing, sorry. I saw my one friend is DJing. So many fun people streaming these days. Let's go say hi to Shark Geek. Shark Geek is doing shark science. Love that. Okay. All right. Enjoy the rest of your Tuesday. We'll see you on Thursday. Peace.
Looking at anything that's a potential stress factor in these animals, which, interestingly enough, you can see here they're actually in Biscayne Bay using red headlights to handle the sharks at night. Yo, actual education, what's up? How you doing? Cortisol factors. Did you already know that's what we were looking at? Was